Alright guys, today we're going to start 7.2. 7.2. It's talking about similar polygons. What's a polygon? Y'all are all right. It's a triangle, and David, what'd you say? It's a four-sided figure. Okay, it's a polygon is any of those things that we can name off. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon. So, any of those shapes. Similar polygons have the same size. Have the same shape. Have the same shape. But not necessarily the same size. Same shape, but not necessarily the same size. So two polygons are similar only if their angles are congruent, and their corresponding side lengths are proportional. What do I mean by that? In order for something to be proportional, they have to equal the same. Okay, what kind of polygon is this? Basic. Not parallelogram, even more basic than before parallelogram. Not square, that's getting more in-depth. Quadrilateral, four-sided, quadrilateral. So, in order for these to be proportional, we have to make sure that the corresponding sides equal the same thing. So the tricky thing is making sure you're going in order. So from A to B needs to be proportional to W to X. Now the reason I'm using dots is because I'm not going to put a dash because they're not congruent. They are proportional. So A to B goes with W to X. B to C goes with X to Y. DC goes with XY. And then this last one, AD, goes with WZ. 3, 4. Okay, you don't have to do the dots if it doesn't help you. I just want you to see which one goes with which. So to tell whether these are similar or not, we need to look at their lengths to each other. So what was the length of AB? 15. What was WX? 5. BC is 12 over XY is 4. Do y'all see where I'm getting these from? AB was 15. 15 over, this side is 5. 12 over 4. 21 over 7. 18 over 6. They're all divided by 3. They all equal 3 over 1. So even though they are different sizes, they are similar. They have the same shape even though they're not necessarily the same size. So you know how we write something is congruent? This symbol right here? That's the symbol for congruency. Okay, this means they are absolutely the same. 12 is congruent to 12. In order to say something is similar, you only use the tilde. This means similar. Similar. So in example 1, triangle ABC is similar to RST. List all the pairs of congruent angles and write a proportion that relates the sides. So remember when we were talking about triangles and we said we have to go in order that it's listed? So if A is listed first, angle A is congruent to angle R. Good. Angle B is congruent to angle S. And lastly, C is congruent to T. Now, similar triangles can have congruent angles. The angles are congruent. but that doesn't mean that the sides are going to be the same. Okay, so let's write what's called a proportion, like we just did up here. Show me what needs to be equal to each other in order for this to be a similar triangle. AB has to go over RS. Good. BC has to go over ST. Awesome. AC has to go over RT. Alright, next important thing is this thing called a scale factor. You're going to hear this term so many times. Yes, ma'am. It's called the scale factor. What this scale factor does is it tells us the ratio of the lengths of the sides. So it tells us the ratio between the two triangles. So here is triangle ABC. A to B to C. And here's triangle XYZ. Okay, I'm going to say that triangle ABC is similar to triangle XYZ. If AB is 6, and XY is 3, I want you to find the scale factor. Scale factor. SF. Not San Francisco. Scale factor. So what I do to find the scale factor is the ratio between the two. How much is it increasing or decreasing from triangle to triangle? There's two different ways to write it, and they're both correct. Okay, they're both correct. You could either say, well, it's 6 over 3, which is what? 6 over 3 is 2. So this one increases by 2 to get here, right? 3 times 2 is 6. The ratio from this XYZ triangle to ABC, the ratio or the scale factor is 2. 3 times 2 is 6. Or, if I want to go from ABC to XYZ, what's the ratio from here to here? Divide by 2. So in that case, the scale factor would be 3 over 6, which is 1/2. You're dividing this by 2 to get here. You're multiplying this by 2 to get here. They're both correct answers. It just depends on the scenario in which you're using it. All right, let's look at example number 2. Okay, so this is kind of a little bit messed up. Both of these right here, both of these are the same thing. And they're both the original. You're going to know what I'm talking about when we read the question. They're both the original. Tan is designing a new menu for the restaurant where he works. Determine whether the size for the new menu is similar to the original menu. If so, write the similarity statement and the scale factor. So this is their original menu. These are two options for the new one. So from here to here or from here to here. One of them is going to be similar and one's not. So let's find out if they're similar. Well, what was the original top of this menu? 10. So that has to be proportional to the top of this one, which is 12. So 10 over 12. 10 is to 12 as the side of the original, which is 12, is to 14. So when we simplify this, we'll find the scale factor. If they're both the same number, then it's similar. So simplify 10 over 12. 5 over 6. Simplify 12 over 14. Are those the same thing? No. So they're not congruent, therefore this is not similar. Okay, another way to tell whether these were equal. Some of you hate fractions, right? Some of you? Okay, just plug that straight into your calculator. 10 divided by 12 is 0.83333. 12 divided by 14, are those the same number? Then they're not similar. Okay? Okay, let's try the second one. In order for them to be similar, they have to have the same ratio. 10 over 8, top to top, over side to side. Plug it in your calculator. See if they equal the same thing. Yes. I got 1.2 equals 1.2. So guess what my scale factor is? 1.25 or 5 over 4. So how would I say this? I would say, what is this? Quadrilateral, ABCD is similar to quadrilateral RSTU. What's the sign for similar? Just a tilde. Right? Isn't that called a tilde? I know. Okay, I want you to finish 1, 2, and 3. Do I need to do one of them with you? Okay. Okay, so let's do number 1. We need to determine whether each of the pairs of figures is similar. If they are, write a similarity statement. This is a similarity statement right here. So such and such is congruent, is similar to such and such. So if they are, we have to write the similarity statement and the scale factor. Okay, so do I need to write the letters out? Do I need to write the letters? Does that help y'all? A to B goes over D to E. Has to be equal to B to C, which is over E to F. B to C. C to A is over F to D. Now fill in the letters. 6 over 4 equals 9 over 6 equals 7 over 10.5. I wrote that backwards. You have to swap those. Do you know why? The top always has to come from the same triangle. 6, 9, 10.5. Bottom has to come from the other triangle. 4, 6, 7. So if I use this triangle first, I have to keep it in the same order. 6 over 4, 9 over 6, 10.5 over 7. If you flip those, do they all have the same scale factor? What's 6 divided by 4? 1.5, so the scale factor is 1.5. And we need to write a similarity statement. Well, have I figured out my angles? What about the angles? Are they all the same? If that's 59 and that's 35, can I find B? 180 minus 59 minus 35. So this one would be 86. Well, if that's 86, so is this, right? It's the same angles. Therefore, triangle A, B, C is similar to triangle D, E, F.